हरि करना।
So far we have seen AI types, and then we have classified AI using functionality, learning type, and application. So now, as we have discussed earlier, weak AI is our universe, ML is our galaxy, and then we have supervised, unsupervised reinforcement as our stars, and inside that we have solar planet as a regression, and then other stuff, and inside that we have our uh, planet as algorithms. So now let's take up the machine learning, and we'll classify the machine learning into first learning type, and then uh, into the various algorithms. So ML and DL, these are both are subsets of artificial intelligence that involve training algorithms to make predictions or decisions based on the data. The main difference between ML and DL lies in the complexity and the amount of data they can handle. But there is one more very important point that makes a huge distinction between ML, machine learning, and deep learning. So that's what we'll see later. But for now, ML algorithms are typically used to solve problems that involve structured data, such as tabular data or time series data, and they rely on hand engineered features. Remember this compound word, hand engineered features, to learn from the data. So for the ML, for the machine learning, you have to do the feature engineering. Okay, so now let's classify machine learning first into the learning types. So supervised, unsupervised, and we also have the reinforcement, and then finally we have ensembling methods. So what is ensembling methods, we'll discuss later. Okay, I'll explain what is ensemble method. Okay, these are the four categories we are gonna divide our ML into. So first, supervised, we have discussed what is supervised machine learning, where the data will be labeled. Okay, we'll use a labeled data, even our target variable also. So supervised, let's see all supervised machine learning algorithms that we have. So supervised can be further classified into regression and other ways. Okay, so first, supervised has been classified into regression. So inside the regression, what all algorithms we have, we will see now. So linear regression, polynomial regression, ridge regression, lasso regression, elastic net, super vector regression or SVM, and k nearest neighbor regression, KNN. And some algorithms can be used for the regression as well as a classification. So Gaussian process regression, decision trees regression, random forest regression, then gradient boosting regression, few more you have. Then this is one classification of supervised. Now the supervised can be further classified into classification, regression, and classification. So classification, we have logistic regression. Again, that using logistic regression, you can do the classification. KNN, K nearest neighbors classification, decision trees classification, random forest classification, Naive Bayes obviously classification, probabilistic one, and super vector mission. I told you we have super vector mission as super vector regression SVR, and super vector mission also for the classification. So regression is basically for the prediction, classification is for the classifying your data into three or more labels. The labels will be pre-decided. That's why it's called supervised learning. Then gradient boosting classification, AdaBoost classification, and bagging classification, and boosted trees classification. And the next type of supervised learning is time series prediction. We have auto regression, moving average, auto regressive integrated moving average, and seasonal auto regressive integrated moving average, and exponential smoothing, and ARIMA models, and these are called a time series prediction. So this is if you use a time series data, and these are the algorithms we are going to use. So let me look into the supervised one. So supervised learning type, these are only ML algorithms, not deep learning algorithms. Deep learning algorithms were excluded. These are specifically ML algorithm. There is a difference between a way of doing ML, machine learning, and deep learning. Though deep learning is subset of machine learning, but there is a clear cut distinction between how machine learning algorithms operate and how deep learning algorithm operates. Okay, so a supervised learning type of machine learning were further classified into regression type, classification type, time series prediction type. So what are these? These are what at the end of the day what you are going to do. That's what the regression say. Regression is nothing but using the data, using the supervised type of learning, we are gonna do the prediction. Using the supervised type of learning, we are gonna do classification. And using the supervised type of learning, we are gonna do time series prediction. So this is what the first one, supervised learning. This is our first galaxy. This is our first star. Next we have unsupervised learning. Unsupervised learning. So unsupervised learning, first classification of unsupervised learning, or let me say the category, because the classification word we are using under the supervised learning na. So that's the reason I'm going to use categories from now onwards. So unsupervised learning has been further categorized into different categories. Out of them, the first one is clustering. So clustering, we have the following algorithms. K-means, hierarchical clustering, density-based spatial clustering of applications with a noise. In short, we call it as a DB scan. DB scan. Then expectation maximization, EM clustering. This we have discussed when we were doing that probability course, intuitive probability course. Expectation maximization clustering, mean shift clustering, then that's it. These are clustering type algorithms. Then we have dimensionality reduction. In dimensionality reduction, principal component analysis, PCA, linear discriminant analysis, LDA, quadratic discriminant analysis, QDA, then canonical correlation analysis, CCA. Then last one, non-negative matrix factorization, NMF. Independent component analysis, ICA, similar to the PCA. Then another category of unsupervised learning, that is association rule learning. So a priori, eclat, and the one more category, anomaly detection. This is also very important. Anomaly detection. Anomaly detection. So one class SVM is used for anomaly detection. Then isolation forest is another algorithm which is used for anomaly detection. And local outlier factor, LOF. Local outlier factor, LOF. Then elliptic envelope. And one more category of unsupervised learning, generative models. Generative models. So Gaussian mixture models, GMM. We have discussed this in random variables course. So hidden Markov models, HMM. This also we have discussed in random variables course or probability course. Hidden Markov models, HMM. And this is all about the categories of unsupervised learning type of machine learning algorithms. Then we have reinforcement learning, and reinforcement learning is further categorized into different categories, out of which value based methods is the first one. Value based methods. So Q learning, SARSA, and second type policy based methods. So Monte Carlo policy gradient and cross entropy method. Cross entropy method. And the third type, model based methods. Model based methods, DynaQ. That's it. So these are the three class categories that we can make ML classifications based on types of learning, and further each type of learning is further categorized into different categories. And the another type of algorithms that we have here is ensemble methods, and this is not similar to the type of learning. It is a separate category. So why do we use ensemble methods? Ensemble methods are a type of machine learning technique that combine multiple individual models. It combines multiple individual models to make more accurate predictions than any of the individual models alone. That's why we call them as ensemble methods. So first we have seen various methods, various algorithms based on the classification of types of learning. Then after intermixing these algorithms, what we get is ensemble methods, and these are these ensemble methods after combining multiple individual models to make more accurate predictions than any of the individual models alone. So ensemble methods work by aggregating the predictions of multiple models, either by combining the individual predictions, example averaging or weighted averaging, or by selecting the best individual prediction based on a voting mechanism, and there are several types of ensemble methods, including bagging. Bagging also called as a bootstrapping or bootstrap aggregating. Bagging is also known as bootstrap aggregating. That's why bagging, bootstrap aggregating. So this we have discussed in intuitive sampling and distribution course in detail. Then we have a random forest and boosting, AdaBoost, gradient boosting, and extreme gradient boosting, or we call it as XGBoost. Then light GBM, then cat boost, and finally stacking. These are called ensemble methods. So ensemble methods can be used with various types of machine learning models, such as decision trees, neural networks, and support vector machines. So anything, it can be used with any other methods, so that you can improve the accuracy of predictions and reduce overfitting. So in a nutshell, this is ML classification based on the types of learning: supervised, unsupervised, reinforcement, and finally ensemble methods.